G'day guys, Mr. Bennett here. Now this is the second video in terms of exercise 4D3 and these are the sort of A-type questions that you might have in a test. Alright, so let's just go through here. Now the first part with any of these is to rearrange the equation in terms of sine of x. Root 3 on 2. And we know we're going between 0 and 4 pi. Now again we're using our unit circle. Unit circle, and we know that sine is negative over here, okay, in these two quadrants. So we're going to drop our right angle up over here. We know that our sine is in fact opposite, and it's going to be minus, and that's 2. That means that this angle here has to be 60 degrees or pi and 3. That angle there is 60 degrees or pi and 3. So if we start thinking about our circle, now that's 3 pi and 3 plus another 1 over there, so that's going to be 4 pi and 3. And this one going around in this direction here, now we know 2 pi is in fact 6 pi and 3, so therefore that's going to be one short of that, which is 5 pi and 3. Okay, those are my two angles that I need to consider. So when we start looking at doing this, we know that x has to be equal to 4 pi and 3, or it's got to be equal to 5 pi and 3, and then we're doing plus k 2 pi, because remember we're going around in multiple circles. So in this particular case, if we're looking at our value, I quite like to do this, which is think about this being in terms of, and that value there in terms of pi's on 3's. Just makes life a bit easy for me. So that's actually 6 pi and 3 that I'm adding each time. Over here, that's going to be equal to 12 pi on 3, isn't it? 4 pi. Okay, so what we need to now do is simply add our values together. So x is going to be equal to 4 pi and 3 and 5 pi and 3. That's when we have a k value of 0. Our k value rotates between, it could be any value really. Because we're going positive, has to be a positive value here. It could be a negative value. It could be any integer. Now, the next thing we're going to do is we're going to add on our particular values of 6 pi and 3. So 4 pi and 3 plus 6 pi and 3 is going to give me 10 pi and 3. 5 pi and 3 plus 6 is going to give me 11 pi and 3. Now that's both less than 12, and so therefore we know that that is going to fit in our region, and that's k is equal to 1. If I add any more, I know I'm going to go over 12 pi and 3, so therefore that's an issue. On here we can also graph this just to make sure that we get it right. Okay, so we've got our sine, just go back to our y equals, we've got our sine of x. We're going to make that equal to negative root 3. Press across and we're going to divide that by 2. I'm going to graph that. I haven't set my region to be between 0 and 4 pi. But you can see there's our 4 pi and 3, our 5 pi and 3, our 6 pi, oh no, that's our 10 pi and 3 and 11 pi and 3. If I change my window to be 4 pi and then graph that, so here's my curve between 0 and 4 pi. It's two full circles. That's 5 pi and 3, 4 pi and 3, 5 pi and 3, and that will be 10 pi and 3 and 11 pi and 3. So these are my points, and they match with what I'm expecting to see over here. Alright, so that's good. I can check to see if I get the right answer. This one over here is slightly different, and I need to consider my curve because I've got a 2 thing in there. I'm going to do the same process though. Let's just do this one here. This is as tricky as they get. Sine of 2x is equal to 1 over root 2. Okay, and that's 0 between x and 6 pi. I'm going to use my unit circle, again like I would normally do. And I know sine is positive there and there. Drop my perpendicular down. I know this is root 2, that's 1, root 2 and 1. So therefore we know that this angle here is in fact 45 degrees, pi and 4, pi and 4. So therefore when I start doing my circles over here, I know I go there, which is pi and 4. That one there is going to be 3 pi and 4, because it's not quite 4 pi. So when we start doing this, it's essentially the same process. 2x is equal to pi and 4, or it's going to be 3 pi and 4. Now that's what 2x is equal to, and then we're going to do plus k 2 pi. Now, because it's 2x, when I actually want to work out what x is, I have to divide those things by 2. So that becomes pi on 8 and 3 pi on 8. And then when I'm adding this bit over here, it's going to be k lots of 2 pi divided by 2, which is k pi. Alright, so you get the idea? The only difference is when I'm doing it, I have to divide the 2. If it was a 3, I'd divide by 3. If it's a 4, I'd divide by 4. So now I'm going to have multiples of k pi's on 8. Right? Now, if I'm thinking about this, okay, so pi is going to be, that's going to be, and that value up there are going to be certainly, that's going to be 8 pi on 8, and this is going to be 6 pi, that's going to be 48 pi on 8. So that's what I'm going to be going up to. Right, when I start looking at my k values now, because we're going positive, right, k0, 1, 2, da 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 da. Alright, so let's do that very quickly. So therefore I've got x is equal to, my first term is going to be pi on 8 and 3 pi on 8, and that's when k is equal to 0. Now, the next value is going to be plus 8, so that's going to be 9 pi on 8 and 11 pi on 8. That's going to occur when k is equal to 1. We're going to have quite a lot of points here, I think. The next value we're going to do is, and I'm thinking about adding 8 pi on 8 to the 9, so that becomes 17 pi on 8. And then the next one's going to be that's going to be 19 pi on 8. God, we're going to have a lot here. Right, so that's going to be occur when k is equal to 2. And then when k is equal to 3, what's going to happen? So I'm going to add another pi 8, so that's going to become equal to 25 pi on 8. And then 19 plus that's going to give me 27. And the next one's going to be 33 pi on 8 and 35 pi on 8. And then I'm going to go 41 pi on 8, and it's going to be 43 pi on 8. And the next one's going to be 49, it's going to be too big. So therefore we know here, the k value here, k is equal to 3, k is equal to 4, and k is equal to 5. So we've got to have a fair few values there. So we've got 2, 4, 6, we've got 8 to 10 points that fit that equation. So what we could do here is simply go to our curve. Now remember we're going to 6 pi, so we'll change our window to 6 pi again. So 6 pi, enter. We're now going to change our function. Our function is no longer y equals sine of x, but sine of 2x. So put that in there, sine of 2x. Our curve over here is going to be, we'll just clear that's going to be 1 divided by the square root of 2. Okay, don't need a bracket in there, delete that. Okay, enter. When I graph that, this is what my curve does. Obviously the sine of 2x means that I get 2 full waves for every one normal wave. Remember I'm looking for 10 points, aren't I? So that's pi and 8, alright, and then that's going to be, what would it work out to be? I can't remember the values. Pi and 8 and 3 pi and 8. So when we go to our curve, pi and 8, 3 pi and 8, 9 pi and 8, 11 pi and 8, so it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, so it's 2, 4, 6, 8, 10, 12. There's 12 points that fit on here. Now, did that match what I had over here? Did I get 12 points? Yes, I did. I got 2, 4, 6, 8, 10, 12. Okay? Because remember, we went up to k equal 5. So that matches exactly what I'm expecting to see with that. So my curve fixes the period. Again, if we want to relate this to an application, it could be that this is the high tide for a period of time, and I can only go out in these periods here. Or it might be an example looking at the sun, and when the UV radiations are at a high point. So therefore, those points here are only points where I can actually, I probably won't go out in the sun because it's too hot. All right, so the rest of the time I can actually be out in the sun there. So there are applications that you'll see when you're doing your questions, but this is the mechanics behind how you find those points of contact with the sine curve.